Hi guys, today's Leetcode daily is maximum value of an ordered triplet. So we are given a zero index in integer array whose name is nums. Now we have to find triplet of indices I, j, k such that I is less than j is less than k. Now we have to find value of this triplet which is equal to nums of I minus nums of j into nums of k. Now in this array there are multiple such triplets possible. So we have to find value for all the possible triplets, and after that for one triplet we'll get the maximum value. We have to return that. There can be possibility that all the triplets have negative value, then we have to return 0. Now we'll see example for better understanding of this question. So like here, this is the given nums array. So if we take triplet containing elements 0, 2 and 4, then we'll get value equal to 77, which is the highest value if we consider all possible triplets. So we'll return 77 as our answer. Now we'll see brute force approach. Like it is very simple. We'll find all the possible triplets. We'll find values for all the possible triplets, and then the triplet which is having max value, we'll return it. Now we'll see code for better understanding of the brute force approach. So we'll take a answer variable where we'll store our answer. Now we'll traverse for all the possible triplets. That is, we'll traverse from I0 to n minus 3. J will go from I plus 1 to n minus 2, and k will go from j plus 1 to n minus 1. Now for every triplet, we'll find its value. After finding its value, we'll see whether this value is greater than the value which is stored in the answer. If it is greater than the previous value, then we'll update this value in the answer. Otherwise, answer will contain the previous value only. After all these three loops are over, our answer will contain the maximum value of the triplet. So we'll return answer. Now, if we talk about time complexity, then we are using these three loops. So time complexity is we go of n cube. If we talk about space complexity, then we are not using any extra vector or array or any other data structure. So space complexity is constant. That is we go of 1. Now, can we do something better? We'll see how we can do something better. So we need to find max value of nums I minus nums j into nums k. So in this, we want our nums I and nums k should be as large as possible. So for that, we'll take two vectors, max of I and max k, where max of I will store the largest element from beginning, and max k will store the largest element from end. And we'll iterate for j and calculate answer using this max I and max k for each j. And at last, we'll return the maximum value which we calculate as our answer. We'll see code for better understanding of this approach. So here we are taking two vectors, max of I and max k. So max of I will store the greatest element from index 0 to I, and max of k will store the greatest element from index I to n minus 1. So now at start, max of I of 0 will be equal to nums of 0, and max of k n minus 1 will be equal to nums of n minus 1. Now we want to fill these two vectors, so we are traversing from 1 to n, and every time we are seeing if the current element is greater than the previous greater element, then we are updating with the current element, or we are updating it with the previous greater element. And for max I, we are updating from the front from index 1 to n minus 1, and this we are updating from index n minus 2 to index 0. Now, when this loop is completed, max of I and max of k will contain what we want to store them. After that, we are just traversing for j equal to 1 to n minus 2, and every time we are calculating the value for that particular j, and if that value is greater than our answer, then we are updating our answer. After this loop is done, our answer will contain the maximum value of the triplet, so we'll return the answer. If we talk about time complexity, then this for loop runs from 1 to n. This also 1 to n minus 2. So time complexity is O of n. If we talk about space complexity, then we are using these two extra vectors which are taking n, which are of n size. So space complexity is also O of n. Now, can we do something better? Can we mm, do this in big O of one space? So we'll see that how we can do that. So in this, we'll maintain max I and max difference value which we have got till now, and we'll traverse for each k. And for each k, we'll find answer by using max difference into k, and at last we'll return the maximum answer. Now we'll see code for better understanding of the implementation part. So we'll take max I, where we'll store maximum value of I we have achieved till now, and in max difference we'll store maximum difference value we have achieved till now. So for the first triplet, max I will be equal to nums of 0 and max difference will be equal to nums of 0 minus nums of 1. Now we'll start traversing for each valid k, that is from 2 to k equal to n minus 1. We'll calculate answer by using max difference into nums of k. If this n- new value is greater than our previous answer, we'll update the answer. Now the k minus 1 will act as I for the next iteration. So we'll see if nums of k minus 1 is greater than our previous max value of I, then we'll update it. Also, this kth index will act as j for the next iteration for k plus 1. So we'll see if max I minus nums of k is greater than max difference, then we'll update it. After this, all the iterations are done, our answer will contain the max value of the possible triplets. So we'll return answer. Now, if we talk about time complexity, then there is only one loop that goes from 2 to n minus 1. So time complexity is O of n. If we talk about space complexity, we are not using any extra array vector or any other data structure. So space complexity is constant, that is O of 1.